Problem number 45. The body in figure is pivoted at O and two forces act on it as shown in the figure. So you can see the figure. We have a body and this body is exactly pivoted at point O, and in this body two forces are acting on it. If R1 equal to 1.3 meter, R2 which is equal to 2.15 meter, and F1 magnitude is 4.2 Newton and F2 magnitude is 4.9 Newton, and theta 1 is 75 degree and theta 2 is 60 degree, what is the net torque about the pivot? So here it's one of the easiest questions. You can see all the values are given and we are going to apply the rule for the torque. In theory, we studied the rule for the torque. What is the formula for the torque? The torque tau, which is equal to R cross F, which is equal to RF sine theta. Now you can see the given in this figure, the body is given and two forces are acting on it, and also from the point O, the value of R1 is given, likewise R2 is given, it's theta 1 and theta 2 is given, all the values are given. The only thing we have to substitute the values in the formula, and after that we have to find the value for the net torque. And also the most important thing in this point, we have to find the direction of the torque, because in theory we studied if the torque is moving in the counterclockwise direction, the torque tau takes the value of positive. If the torque is moving in the clockwise direction, it takes the value of negative. Clear? We have to be very careful about the sign. If the torque is moving in the counterclockwise direction, it takes the positive value. If the torque is moving in the clockwise direction, it takes the value of negative, because here two torques are acting on the body. First of all, let's write the given. For the first torque, R1 value, which is 1.3 meter, and F1 value, which is 4.2 Newton, and then theta 1 value, which is 75 degree. Likewise, R2 value here is 2.15 meter, and then F2 value here is 4.9 Newton, and then theta 2 value here is 60 degree. Now what I'm going to do, by using the first set of the values, I'm going to find the value for torque tau 1, and then by using the second set of the data, I'm going to find the torque tau 2, and then I'm going to add these two torque for finding the answer for net torque, because the formula for the net torque is given by the rule torque tau 1 plus torque tau 2. So what we need the value for torque 1, tau 1. By using these values, I'm going to find torque tau 2. So let's substitute the values on the formula. So what is our values? I'm going to find the torque tau 1. So I can just make a line. So torque tau 1, which is equal to R1 F1 sine of theta 1. R1 value is 1.3 and F1 value is 4.2 multiplied by sine of 75 degree. So let's see the value for the torque. 1.3 multiply 4.2 multiply sine of 75 degree. I got here as 5.27, and the unit for the torque is Newton meter. Clear? This is our torque tau 1. Now by using the second set of the data, I'm going to find torque tau 2. So tau 2, which is equal to R2 F2 sine of theta 2. So R2 value here is 2.15 multiply 4.9 multiply sine of 60 degree. Let's see what is the answer. So 2.15 multiply 4.9 multiply sine of 60 degree. I got the answer here as 9.12. 9.12, and the unit for the torque is Newton meter. So we got the torque tau 1 and torque tau 2. Now the most important thing, we have to find the direction of the torque. As I already mentioned earlier, if the torque is in the counterclockwise direction, it will take the positive value. If the torque will be in the clockwise direction, it will have the value of the negative. So let's see the figure closely. So you can see here, first of all, I'm going to consider torque tau 1. you can see R1 and F1. For getting the maximum torque, the angle between R1 and F1 should be 90 degree, but here our theta 1 is 75 degree. So for getting the maximum torque, which directions you can pull this F1 vector? You have to pull this vector to the counterclockwise direction. That means here your arrow mark should be in the counterclockwise direction. So what we studied, for counterclockwise direction, the torque will take the positive values. That means the answer for tau 1 here is positive. Likewise, we have to check for the second set of the data. This is your theta 2, which is 60 degree. So for getting the maximum torque, this is our 90 degree. So for getting the 90 degree, you have to take this arrow to the clockwise direction. So for the clockwise direction, we will get the sign as negative. So here for the second torque, tau 2, the sign should be negative. Why? Because the force is moving in the clockwise direction. Now what I am going to do, I am going to substitute the value for finding the net torque. What is the formula? Net torque, tau net, which is equal to torque tau 1 plus torque tau 2. I am going to substitute the value here. The value for torque tau 1 is positive value of 5.27 plus, and its unit is Newton meter, right? And then for torque tau 2, what is the answer? Minus of 9.12 Newton meter. So here we have to get the clear picture about the sign, because plus into minus is minus. So 5.27 Newton meter minus 9.12 Newton meter. Let's see the answer. 5.27 minus 9.12. I got the answer here as minus 3.85. Minus 3.85 is our net torque, and the unit for the torque is Newton meter. So this is our net torque. Clear? So this is the answer for this question. That's it. Thank you.